Hello there and welcome to the lab on lights and cameras. In this lab, we're going to look at lights and the different types of lights available in the Unity platform. And related to that, the use of halos and cookies with lights, and the idea of cameras, having multiple cameras in your scene view, and how this works out in terms of what is displayed in the game view, and the concept of layers. So let's start off by looking at lights and the different types of lights available in the Unity platform. The idea of lights is to increase the sensation of realism or to provide a dramatic effect in a scene. So for example, if you want to have a scene where things look very gloomy, you have a darker light. If you want to have a scene where things are more cheerful, you have a brighter light. And of course, the color of the light also influences the mood of a particular scene. Now in Unity, lights are components, which means when you add a light to a scene, you are actually adding a game object with the light component. So the light is not an actual game object, it's a component that you add on to a game object. There are three different types of lights: point light, spotlight, and directional light. There's also a type of light called area light, which is used for a process called light map baking, but this is only available in the professional version of Unity. Since we are using the free the free version of Unity, we will only work with these three different types of lights: point light, spotlights, and directional lights. Let's look at the point light. The point light is similar to a light bulb. The light is emitted from one central location out into every direction, and it is the most common type of light for illuminating interior areas. So a light bulb, a point light will have several different types of properties. The first one is the type, which is basically to say whether it's a point light or directional light or a spotlight. The range, how far the light goes to, color of the light, the intensity, how strong the light is, the cookie, whether the light throws a shadow or not, whether you want to draw a halo around it, and whether you want to use a flare to create simulation of a bright light shining into a camera lens. Okay, then the random mode determines the importance of this light, and the culling mask determines what layers are affected by the light. So we look at that later on when we examine the topic of layers. So let's switch over to Unity and work with a couple of point lights. Let's switch over to Unity here. And I'm going to add a couple of things, game objects to this empty scene in order to demonstrate the use of lights. So first thing I'm going to do is I'm going to create a plane. Okay, so go to the hierarchy view, create plane, and I'm going to put these coordinates for the plane. X will be 0, position the Y will be 0.5, and Z will be 0, and rotate the plane on the X-axis by 270 degrees. Y will be 0 and Z will be 0. So you've done this properly, you should see something like this. The plane should appear in front of the camera. Let me rotate this because right now we are right behind the plane, we can't see it. So I'm going to click on the hand tool and press the alternate key to rotate so that I can actually see the plane. So now I can see the plane. I'm going to move out a bit. Okay, so now we've got the plane in the scene view. Okay, next I'm going to add 2 cubes to the scene. So I'm going to say create cube. And I've got 1 cube. I'm going to duplicate this and create 2 cube objects. I'm going to rename these cubes Cube 1 and Cube 2 for simplicity's sake. Rename Cube 1. Rename Cube 2. So I've got 2 cubes. Now for Cube 1, the values of the X, Y, Z are going to be negative 1.5 for X, 1 for Y, and negative 5 for Z. Okay, and for cube 2, it's going to be 1.5, 1, and negative 5. Oops, this is not done properly. Let me just click that negative 5. So we've got 1.5, 1 and negative 5 for cube 2, and cube 1 we've got that at negative 1.5, 1 and negative 5. Okay, 1.5, 1 and negative 5 for cube 2, negative 1.5, 1 and negative 5 for cube 1. Okay, great. So you've got two cubes now, we've got a camera that's at the moment projecting everything onto the scene. Currently everything is dark because there's no ambient light yet. And now we're going to introduce a point light into the scene. So we're going to say create point light. Okay, so now we've got a point light, and we're going to position this point light at 0. Position is going to be 0. X position is 0. Y position is 1. And Z position is negative 5. Okay, so we've got the light between the two cubes, okay, that we've just created. And you see how the light illuminates the inner sides of the cubes and the background plane as well. Now, if I click on the, let me switch back to the translation tool by clicking on this icon at the upper left hand corner of the interface. Okay, now if you notice here, if I pan out a bit, you can see that there's kind of a large yellow circle that is around the entire scene, or at least around this particular part of the scene, and this is actually the range of the point light. Okay, so let me move in a bit closer. Now let's try and see what the effects of moving the point light around the scene. Okay, so if I move it up on the y-axis, notice how the view on the game view changes as the light source goes up and down. On the y-axis, I can drag it right and left, for example, as you can see here, right and left, or front and back. Let me see whether I can get the, okay, I've got that. Okay, front and back. Okay, no, I'm sorry, I'm on a wrong plane here. Okay, so as you can see, when I drag this out further away, everything fades away. If I drag the light source in closer to the plane, it gets brighter. When the light source goes through the plane, okay, it vanishes. The cubes are no longer lighted because the light cannot penetrate the plane. So I drag the light source back again through the plane and then up to a stage where it's again somewhere between the camera and the plane. Okay, so let's zoom up a bit again. Now, as I said just now, this this kind of outline of this yellow sphere with these circles here is representing the range of this point light. So if I go to the inspector view, you can see there's a value called range for the light component, and you can change this value and you see the size of the circle change as well, and also what is being displayed on the plane through the game view, okay, will also change. So if I change the range to 1, for example, the range on the light is not enough to hit the cube, so you don't see anything on the plane. I change the range to 2. Okay, so I'm going to change this to 2. Oops, sorry. I'm going to change this to 2. Okay, so you see the circle gets bigger. I'm going to change it to 3, 4, 5, 6, okay, 7, 8, 9. Okay, so I can change the values of the range. Now here the color of the spotlight is white. I can change obviously to other colors as well. So for example, I can change to this color. Any kind of color range I want, blue, green, okay, anything I want, I can select the color. Okay, the intensity value reflects how intense the light is going to be. So if I drag it, you can see the light becomes more and more intense, very, very intense. At 8, it's the highest level intensity. I drag it all the way back down to 0, and then the light does not come out. The light doesn't show at all. The light doesn't come out at all. There's no light emitted. So it ranges from 0 all the way up to 8. Okay, and of course you can, and this is available through the inspector view. Okay. Now, light source can also throw shadows. Let me switch this back to white so it looks a bit more normal. Okay, so I'm going to switch this back to white. Now, right now, the as you can see in the game view, the cubes, there are no shadows that are thrown behind the cubes. So normally what you expect is when there's a light source in front of the cubes and the cubes are not opaque, they are solid, then there should be a shadow behind the cube displayed on the plane, but you don't actually see that, okay, because that's not currently supported in the basic version of Unity, the free version of Unity that we're using. So if I try to turn on hard shadows, it tells me that only directional lights, if you look at the inspector view, it only tells me only directional lights have shadows in forward rendering, and real-time shadows for point and spotlights require Unity Pro. So I can't work with shadows for the case of spotlights and point lights. I can only do that in Unity Basic in directional lights, which you're going to see later. So I'm going to switch back again to no shadows. Okay. Now let's now introduce a what's this? A spotlight. So to do a spotlight, what I can do is I can again go to the hierarchy view, create, and then create a spotlight. But let's change the existing light that we have into a spotlight, and that's very easily done. I highlight the point light game object in the hierarchy view, go over the inspector view. At the type field, I click on the drop down box and I change this to a spotlight. So now it becomes a spotlight. Okay, go back to the scene view, I zoom in a bit, see it more clearly. Okay, so here is the spotlight now. You can see the spotlight. And we're going to give some values to the spotlight. I'm going to move it out a bit. I'm going to set the position of the spotlight, okay, to position X is 0, Y is 1, and Z is -13. Okay, so 0, 1, and -13. So you can see that we have the spotlight now. That's actually kind of behind the camera. And it's projecting in a cone space. It's projecting out in a cone shape onto the plane. Okay, and so you can see the two cubes there as well reflected. So again, we can change the values of the range if we want for the spotlight. So we saw before, if you have a low range, it's not going to come out at all. So if you go back to the inspector scene view, I can change the values for the range, play around with that, and see how the light from the spotlight extends further outwards in terms of a cone as we increase the values of the range. Okay, range is 6, range is 7, range is 8, range is 9, range is, let's put it at 12, for example. Now the spot angle actually shows or allows you to change the radius of the circle or the spotlight. Okay, so now the radius is at 30 degrees. If I increase it, you see the circle gets larger and larger. Okay, so if I decrease it, it gets smaller and smaller. And if it gets too small, right now it's pretty small. As you can see now, it's pretty small. So none of the, or only a small part of the cubes are actually highlighted in the game view. Okay, so let's change the spot angle to something nice where it can encompass both the cubes. Okay, we already saw color intensity is pretty much the same thing as well that we had seen earlier for the case of a point light. And again, with the with the spotlight, you cannot have any shadows in Unity Basic. So if you try to create a shadow, you get again the same message that tells you only directional lights can have shadows in forward rendering. Real-time shades for point and spotlights require Unity Pro. So we turn off no shadows here. We go back to the no shadows option for the shadow type field in your inspector view. Okay, so that is a spotlight. Okay, sorry, I missed this. So I missed talking about spotlight. So the spotlight, the light of a spotlight begins in a central spot and radiates out in a cone and can be aimed, as what we saw earlier just now. Illuminates whatever is in front of them only and leaving everything else in the dark. And the spot angle property determines the radius of the cone of light emitted by the spotlight. Now let's look at the directional light. The directional light is like a sun in that it illuminates the entire scene. So it doesn't matter where the location of the directional light is, the scene will be fully lit in that particular direction. Okay, so the directional light doesn't actually change the light So when you move a directional light around the scene, you don't actually see the lighting effect on the scene change, but you will see the shadows actually change depending on where the angle of the directional light is coming from. Okay, the light from a directional light is radiated in parallel lines across the scene, and the cookie size properties controls how big the cookie is and how many times it is repeated across the scene. We'll look at adding cookies into our lights at a later point in this lab. So let's switch back to Unity and let's look at a directional light. I'm going to take out this light here. Okay, I'm going to delete this point light and I'm going to create a directional light. So now we've got a directional light. Now I'm just going to move this directional light out a bit. Now you notice no matter where I move the directional light to, so now we've got this directional light here, so I'm moving it up here, right? Let me just switch axis. So you see the directional light is actually behind the plane. So it doesn't really matter whether the directional light is here or down here, or whether you drag it to the left and right. I mean, it doesn't matter where the directional light is, okay? It doesn't matter where the directional light is, okay? The lighting in the scene remains the same because it is almost like there's a large sun in the scene and the sun is coming down at a specific angle and it's lighting up the scene. Okay, and the angle at which the light is coming down is indicated by this these yellow arrows here. So let's switch back again to the scene. Okay, let me just scroll up a bit so that I can see this a bit more clearly. Okay, so let's look here. Okay, here. Okay. Now, the only difference, as I mentioned earlier, is that with a directional light now you can actually throw shadows. So I'm going to go over to my directional light and I'm going to say hard shadows. I'm going to go to the shadow type field in the inspector view with my directional light highlighted in the hierarchy view, and I'm going to click on hard shadows. Okay, and so now I'm going to be able to see shadows on the plane, depending on the angle at which the directional light is coming into the scene. So let me click back onto the directional light and I'm going to switch to the rotation icon in the toolbar at the upper left hand corner, and now I'm going to kind of rotate the light now. Okay, so now as you see, as I rotate the light, okay, look carefully. As I rotate the light, you can see a shadow being thrown by the cube to the plane because the cubes are in front of the plane, so the shadow is thrown to at the back onto the plane. So as I rotate, the angle at which the directional light illuminates the scene, you can see the shadows moving. Okay, you can see that moving in the scene view. You can also see it moving in the game view. Now, remember that you also need to have the shadow option enabled for both these cubes to work. So if you click on either one of these cube game objects, you will see that the mesh renderer component in the inspector view has got two checkboxes, one for cast shadows and one for receive shadows. So if you uncheck the cast shadows, the shadow for that specific cube will no longer appear. So you have to make sure that for the mesh renderer component for this particular Cube 2 game object, the cast shadows checkbox is actually checked in the mesh renderer component in the inspector view. Okay, so that's a directional light. Now let's remove the directional light now. Okay, remove directional light. Okay, and our scene goes back into darkness again. Now, in addition to creating lights, you can also actually create lights out of an existing object. So just now we just worked with lights directly in and of themselves, but we can also put a light into an object, or we can create a light out of an existing object. So let me create a let's say create a sphere. Okay, let me create a sphere, and let me just drag this sphere a bit out. Okay, so we can see the sphere here. Now what I'm going to do now is I'm going to add a light component to this sphere. So there are two ways to do this. One is to go to the inspector view and then click on add component, and then click on rendering, and then click on light. Okay, that's one way of doing it. The other way of doing it is you just go to your main menu, click on component, click on rendering, and then click on light. Okay, so there are two ways of adding a light component into an existing game object. So now this game object, which is the sphere, basically has got a light component in it. So, and this light component is of the type point, and you can see that the effect on the plane is basically of a type expected with a point light. Okay, and of course I can change these to, for example, a spotlight, and then of course you see it changes as well correspondingly. I can change this to a directional light, and it changes correspondingly as well. So I can change it to any kind of light I want, as well as we saw just now when we were talking about those three different types of light. Okay, so this is an example of putting a light component into a game object. Okay, let's go back to our slides. Now let's look at halos and cookies. Halos are glowing circles that appear around lights in foggy or cloudy conditions, and they occur because light is bouncing off small particles all around the light source. Whereas cookies are special textures that you can add to lights to dictate how the light radiates. So it's kind of like you want your light to go forward, and there's some kind of pattern or some kind of symbol that appears with the light. If you recall the movie Batman, you remember that there's a spotlight that will shine into the sky, and then there's a picture of a bat. You know, so that is the kind of concept that you want to have with a cookie. And the cookie, the way it actually displays on a plane where the image is formed on, will differ slightly for point, spot, and directional lights. Spotlights and directional lights, we both use black and white flat textures for cookies. Spotlights will not repeat the cookies, but directional lights will, because directional lights light up the entire scene. And point lights also use black and white textures, but they must be placed in a cube map. So think about these points if you wish to use a texture with any one of these three types of lights. Let's look at this in Unity. So let's go back. I'm going to put in another, okay, the light source that I have now. So the light source I have now is currently from a sphere. Okay, let me just remove the sphere and put in a new light source. I'm going to remove the sphere. I'm going to put in a new point light. Okay, I'm going to drag this out a bit. Okay, so I've got a new point light in the scene now. Okay, now what I'm going to do now is I'm going to create a halo effect. So what I'm going to do, I select the light, and then I go to component, I click on effects, and then I choose halo. Okay, so you can see like there's kind of a halo, I guess, this effect that you see around the point light. We can see it from several views if you want. So this is from the left view, and we can look at it from the back, also from the right, from the top. Okay, so these are different views for this light, for the halo. And if you go to your inspector view, you can see the halo component there. Of course, again, you can change the color if you want to change a different type of color for the halo. And you can change the size of the halo, which is the size of that circle of fuzzy light around the point light. So now it's originally at 5. You can change it to 6, 7, 8, 9, and so on. So you can change the size or the radius of the halo emanating from the light. In addition, if you click on the main menu, go to edit, and you click on render settings. Okay, you will get the render settings in inspector view, and there are two fields related to the halo. The halo strength here can range from the value 0 to 1, reflecting how strong the halo is with respective to the original value that we set for the halo. And also the texture for the halo, if you want to put a texture on it. So right now we don't have any particular texture, but if you want to, you can click on this small circle to the right of the field, We could, for example, choose a default particle texture if you want. You can see how it changes in the scene view and also in the game view. Okay. Now let's go back again to the scene. Let me click on the point light. Now you notice that the halo isn't immediately obvious in the camera, because if we again go here, the camera is the camera is too close to the halo to actually capture the halo properly. So what we're going to do now is to actually see this effect of the halo. We're going to go back again to the camera. I'm going to pull the camera out a bit. So let me just pan the scene view up a bit. Now I'm going to actually pull the camera back a bit and click on the main camera. And now I'm going to actually pull the main camera back. So as you see, as I pull the main camera back on the Z-axis, the halo now becomes more obvious. When I pull it to the front, okay, when the camera goes into the field of the halo is no longer visible. What you see projected onto the plane is basically the effect associated with a normal point light. So you don't see the halo until the camera is at a suitably far away distance from the point light that's emanating the halo. Okay, so again here, if I can click on the scene gizmo to go back here, you can see now the camera is actually quite far away from the point light that's emanating the halo. So the halo appears clearly in the game view.